Answer this one. So let's start with redox reactions again. And I told you that it's the gain of electrons and loss of electrons. Okay. And we talked about oxidation state increasing, decreasing. This was important that whenever you see oxidation state decreasing, that's reduction. That's a gain of electrons. Whenever you see the charge or the oxidation state increasing, that's a loss of electrons, right? So we talked about oxidation state, and you should be able to quickly identify how many electrons are being gained and how many electrons are being lost. Okay, so let me just take this down. For example, okay, let's do a few more reactions. Here's Cl minus one, it's going to Cl plus one. Lubena, what's happening? Oxidation or reduction?
Oxidation.
And how many electrons are lost?
Sir, is it +7 or?
Plus seven. So how many electrons are lost? Is this clear? I said, what's happening over here? You have Fe plus 6 turning into Fe. Loss or gain of electrons, reduction or oxidation?
Reduction.
Okay, so that's a gain of 6 electrons. Okay. So you should be able to exactly figure out what's going on. Anyways, we talked about oxidation state yesterday just briefly, and I told you that oxidation state is not exactly charge. When we talk about oxidation state, we don't always mean charge. It's a charge on an atom in a compound, on atom of compound, if the compound was ionic. Uh, so, for example, NaCl actually has a charge, plus one and minus one. HCl, on the other hand, has no charge. It's a covalent molecule. But since we are more concerned about who's gaining electrons, who's losing electrons, anyone who even partially gains an electron, we just call it minus one. So, for example, you have HCl. Cl is more electronegative. So we're going to say that Cl, the electrons would be closer to Cl. So let's assume that Cl has gained those electrons, and that's minus one, and H is getting oxidized, so that's plus one. Is this idea clear?
Yes, sir.
Okay, so we did that for F and Cl as well. We can do a few more questions like that. Like if I have a molecule of, based on this electronegativity thing, let's say I have oxygen with fluorine, right? What do you think, just purely based on electronegativity, what would be the charges if this compound was ionic? What would be the charges on oxygen and fluorine? Like, who would be gaining electrons in this? Who's more electronegative?
Fluorine is more electronegative.
So fluorine's more electronegative.
Fluorine gains electrons.
So this is going to be minus one. This is going to be minus one, and this would be plus two, right? So now, similarly, you have let's say hydrogen peroxide. So what do you think would be the charges on each of the elements if this was ionic? Like, who would gain these electrons over here in this bond? I mean, it's just
So hydrogen would have +1 charges and oxygen would have -2.
would it have? I mean, hydrogen would have plus one definitely, right? Because these electrons would be closer to oxygen, right? So oxygen would be gaining how many electrons? I mean, what? How many electrons would this oxygen gain? It's going to gain one from
Wouldn't
this.
it be 2 because oxygen is also, the other oxygen also has a bond between.
No, but would it be gaining those electrons or not? Or would it be, I mean, would these two electrons be perfectly shared?
They would be perfectly shared.
So that means no one is actually gaining or losing these electrons. So There's a tie over here, but this one definitely oxygen is gaining, right? So oxygen would only be -1. Okay, is this clear?
Yes, sir.
I mean, these were exceptions. So now the thing is, you can't really go on like similarly you have SO4 -2 and other molecules. You can't really do this for all the molecules. So the simple table that you have to follow is there would be a lot of exceptions. Remember, when in doubt, just start focusing on the electronegativity thing. So the table of oxidation states is that you're going to use is that any free neutral element that's zero, it will have an oxidation state of zero. So if sodium is alone, if any element is not bonded to anything, a second. Acha, so you've got free neutral element that would always have an oxidation state of zero. And the other one is what would happen in compounds if elements are forming compounds. What's going to happen is that group one is always going to be +1. Uh, no exceptions. Group two is always +2. That's again no exceptions. Group three is always losing electrons, so that's also +3. Only the metals. I mean, it's down the group. It kind of gets confusing. They have multiple oxidation states in group three as well. But we're talking about the top ones. Then you have transition metals, kind of variable oxidation states, and finally you have oxygen is -2, but with a lot of exceptions. Like the exceptions are hydrogen peroxide. We just did that, or with F, right? And hydrogen, on the other hand, is mostly +1. Again, it also has exceptions, except when it's with metals. Because when it's with metals, then the metals are the ones that are losing electrons, like NaH. Then Na would be the one that's +1. H would be H is going to be -1. So so you got oxygen, which is -2, and H, which is +1. And fluorine is always -1. I mean, you can always count on that. No one is able to take away electrons from fluorine. It's always -1. I said, so ये table है that has to be that you have to memorize. You have to remember. You probably already do. Based on this table, you can figure out the oxidation states of different things. For example, if I have, so what's the method of actually finding oxidation states of all the other substances? So if I have Cr2O72 minus, so what would be the method of finding oxidation states? The unknown would be taken as X, or take it as Cr or X, whatever. You don't know what the charge on Cr is, and there are two of them. What's the charge on oxygen? That's -2, and there's 7 of them. The total charge must be equal to the total charge on the ion, which is -2. And if you solve for this, X would come out to be equal to +6, right? Is this clear?
Yes, sir.
I said then, so you can do this for let's say P4O10. I need to figure out what the oxidation state of P4O10 is of the elements. And remember, when we talk about oxidation states, we're talking about the oxidation state of the single atom, not of the 4 phosphoruses combined or the 10 oxygens combined. Now, phosphorus, I don't know. Oxygen, I do know that's -2, and there are 10 of them. Phosphorus, let's take that as X, and there are 4 of them. And together they should be equal. It's a neutral molecule, so they should be equal to 0. You do that, and it's going to come out to be 4x is equal to minus plus. It goes to the other side. It's going to be +20. You get rid of the 4, and that comes out to be equal to 5. TK, is this clear?
Yes, sir.
As I either do these questions, I have IO3 minus 1. Tell me the oxidation state of that. I've got HNO2. Tell me the oxidation states of, I mean, you already know what H and O are. I've got H2PO2 minus 1. I've got SF6, right? Uh, Try working out, TK. Quickly try and tell me what the oxidation state of each one is.
Iodine is +5.
TK.
Nitrogen is +3.
So, TK. What's P over here?
+1.
TK, that's coming out to be +1, yes.
Sulfur is +6.
So sulfur is +6 because fluorine would be -1. As anyway, so you can figure out the oxidation states of all the elements, and always remember that in a redox reaction, it's not. Always remember that oxidation state is kind of different than charge. It can be the charge, but a lot of times it's not the actual charge. As anyway, so you have these redox reactions. Now, redox reactions consist of two half reactions. One of them is you can either study them combined or you can study them separately. A redox reaction is it's a combination of reduction plus oxidation. It's always both of the things would be happening together. If only one of them is happening, that's known as a half reaction. Because if somebody loses electrons, there must be someone else that would be gaining electrons. So the two things would work together. So there would be two half reactions, which would combine to form a redox reaction. So this is the half. There would be an half equation for reduction and a half equation for oxidation. But most of the time, you get the full reaction. So your full reaction is that, let's say I have this reaction. I've got sodium reacting with aluminium, which is +3, and it produces Na+1, and at the same time it produces Al, right? So the question is, and who's losing electrons, who's gaining electrons? That's the first thing. Who got reduced?
Na is losing electrons and aluminum is gaining them.
So Na has clearly lost electrons, right? And aluminium has clearly gained electrons, and it has gained 3 of those electrons, right? So the next thing is, since this is a redox reaction, a redox equation is not going to be balanced until the number of electrons. I mean, it looks balanced because the Nas are equal and the aluminiums are equal, but the redox equation is not going to be balanced until the number of electrons lost and gained are equal. So for that, because the number of electrons that are lost and the number of electrons that are gained are not equal, so I would have to multiply this by 3. So there should be 3 sodiums. Is this clear?
Yes, sir.
So in a redox reaction, your electrons gained and electrons lost, they have to be made equal. So let's try another equation, a simple one. So I've got Fe3 plus, and I've got not this. So this is the equation. Can you tell me exactly how would you balance this? And this is one. Who's gaining electrons? Who's losing electrons?
Copper is losing them, and iron is gaining them.
And it lost exactly one electron, right? And Fe, on the other hand, it ended up gaining. It gains 3 electrons, right? So, what would you do?
Multiply the copper by 3.
So you're going to multiply the copper by 3. You need to make the number of electrons lost and gained equal. So balancing redox equation is kind of simple. The only problem is that they won't give you. I mean, they wouldn't tell you the charges in the equation. You would have to find them yourself. So just a second, let me open and write an equation. Just a second. So this one. So let me just first copy an equation. So I have an equation which is I mean you'll be able to see it. Let me copy this first. So I've got Cr2O72 minus, and it's reacting with HNO2, and there are H plus one ions in it as well, and it's forming Cr3 plus NO3 minus one, NO3 minus one, plus there is H2O. This is just 1 second. NO3 minus one H plus one HNO2 and so, so here's your equation, and you have to balance this. Now try doing exactly the same thing. The only difference is, the only difference is they didn't give you the charges. So can you first tell me the charge on each of the elements, especially the ones that are getting oxidized and reduced? What is Cr in the first one?
Plus 6.
So Cr is, I mean H and O you already know. Cr is plus 6. What is N over here?
Plus 3.
So that is plus 3, and Cr is, I mean, it's obviously plus 3, it's given. What is N in NO3 minus 1?
Plus 2.
No, it's not plus 2.
Plus 5.
Okay, this one is plus, this one is plus 5, and H is, I mean, so these are the ones that are getting oxidized and reduced, right? Who got oxidized?
Uh, Nitrogen.
So nitrogen clearly got oxidized and goes from plus 3 to plus 5. So that means, uh, just a second. So it lost 2 electrons. What happened to Cr? Gain how many? So it gained. So it gained 3 electrons. Now the situation is that now the thing is it's losing 2 electrons. So what do you multiply the first one and the second one? How do you make them equal? What do I multiply this with?
By
Kitna by 3? And this by 2, right? So there should be 2 CRs, and there are 2 CRs over here already. There should be 2 CRs over here as well. So I'm going to multiply that by 2, right? Achha, N, how many N's? There should be 3 of them. So multiply this by 3, and there should be 3 ends over here as well, and I'm going to multiply this by 3 as well. Is this clear?
Yes.
So it's the same thing. What we did over here, we are doing the same exact thing over here. So the underlying substances are already balanced. I should not change their ratios now, because if I change them, the number of electrons gained and lost, I mean, they would no longer be equal again. I need to balance the rest of the equation. So there's water and H that's left. You can count the, what do you count? You count the oxygens, 7, and I think how many? So that's 7 plus 6, how much? What is 7 plus 6? That's 13. Just let me confirm. That's 7, and there are 6 over here, so that's 13 oxygens. Then 9 over here, so I need 4 oxygens over here, so that would be 4. And we can balance out the hydrogens now. So I've got 8 hydrogens over here. There are 3 hydrogens already here, so there should be 5H plus 1. So is this clear?
Yes, sir.
So I'm going to give you another equation. You balance it the same way. Where's the equation? Just one second. Let me copy it. So this one is, so it's IO3 minus 1 plus N2O. So when I copy this equation and send me a snapshot of the balance equation on the WhatsApp group. TK बस and I'll try and okay, I'm going to send you the whole thing. Just one second.